we're going to look at the second part of example 1, investigating the velocity of an object that's being fired into the air. In part A, we computed two average velocities of our object. The first one was between using a time interval from 1 to 4 seconds, and the second one was the average velocity from 1 to 3 seconds. In the second part of this problem, we are asked to use average velocities in the table to estimate the instantaneous velocity of the object at t equals 1 second. So let's look at this question for a minute. We know what average velocities are, but now they are asking us to find an instantaneous velocity. And the instantaneous velocity tells us how fast an object is moving at one particular point in time. Imagine our object, our ball that we looked at in the previous video. So our object, our ball, had a speedometer attached to it. It starts on the ground, it's being fired up into the air, it's going straight up, and as it's going up, it's slowing down. And at some point, it moves around and then it's coming back down. So if there was a speedometer attached to it, the readings on that speedometer would be very different at any moment in time. And so we would like to know, what would this speedometer reading be right at t equals 1 second? So if we just looked at the object right then, how fast is it going at that moment in time? Now, we have no idea how to compute instantaneous velocities. All we know how to do is compute average velocities. And so let's look at those. We have a table right here with a bunch of average velocities. And I'm going to add a column on the left right here for our time interval. And so that first, let's look at this table and see if we can understand what the entries are saying. In the first row, we have h is equal to 3, and then we have average velocities right here for different time intervals. And the time interval is just given as a time interval from 1 to 1 plus h. And so the value of h in the first column is the same as that h right here in our interval. So if we are computing the average velocity starting at 1 and going to 1 plus h for h equals 3, that is really the time interval from 1 to 4. And we computed that the average velocity on the time interval from 1 to 4 was 20 feet per second. All these units right here are feet per second. For the second entry, the second row in our column, we have a shorter time interval. We are looking at h equals 2. We already looked at that as well. So this is a time interval from 1 to 3. From 1 to 1 plus 2, which is 3. And that was 36 feet per second. The other entries are new. We did not compute those ourselves, but we could. Somebody else already did this for us. So we don't have the tedium of having to do that, but we can still see what time interval we're looking at. So we're looking at the time interval starting at 1 and lasting 1 second. So that is a time interval from 1 to 2. And apparently there, the velocity, the average velocity, if we are just looking at a 1 second time interval, is 52 feet per second. So what is happening here? I'm going to write down the other time intervals. So from 1 to 1.1 seconds, from 1 to 1.01 seconds. So they're getting shorter and shorter and shorter. And the last one is 1 to 1.001 seconds. So that is just 1/1000th of a second that this time interval lasts. And on those remaining time intervals, we are having velocities of 66.4 feet per second, and then 67.84 feet per second, and finally 67.984 feet per second. We are looking at shorter and shorter time intervals, And our velocities seem to be approaching a number that's very close to 67.9 feet per second. Maybe if we kept going, we would get something that approaches 68. That would be my guess, that this approaches 68 feet per second. And we are really just looking at an instant in time now. I mean, 1/1000th of a second is very short. We are still computing an average velocity, but over such a short time interval that we can almost call it instantaneous. And that value is 68 feet per second. So this is what we mean when we are talking about instantaneous velocity. We can use average velocities to get an idea about how fast or what the value of the instantaneous velocity of an object is. Now we can also look at these numbers graphically. Let's go back to the graph. In our graph we see the two slopes that represented the average velocities from 1 to 4 and 1 to 3 seconds. What we just did was we took shorter and shorter time intervals. We had one time interval from 1 to 2 seconds, and we computed the slope. And then we had shorter and shorter time intervals. So we computed slopes of lines that go through points that are closer and closer together. And ultimately, we are approaching the slope of a line that just barely touches our graph at t equals 1 and f of 1 at this point right here. So this is 1 and f of 1. Those are the coordinates of that point. And our instantaneous velocity represents the slope of that line right there. And a line that is created in this way is called a tangent line. We call this a tangent line. It touches the graph right here at the point 1 and f of 1, but it doesn't really go through a second point on the graph, which all the other secant lines do. And so this line is called a tangent line, and the slope represents our instantaneous velocity. I'm going to put that down here at the bottom of the page to complete our notes. Graphically, the instantaneous velocity of the object at t equals 1 is given by the slope of the tangent line to the graph of f at t equals 1.